Okay, so this is the foundation revision session for paper 1. I'm just going to go through, hopefully you've seen this revision list. I'm just going to go through each of the objectives on here. I'd encourage you to pause the video, have a go at the question, and then I can go through it after. So yeah, have a go at each one as we go along. Okay, first we've got to write these numbers in order of size, start with the smallest number. So I'm going to do a question for each of these objectives that you'll see on the paper. We've got the Hegarty numbers here if you did want further practice, but hopefully this will help you to go through them. So firstly, we're ordering numbers. So we're going to start with the smallest number. Now, for this, we need to understand that we've got place value. So where your decimal point is, we've got the ones column here, or the units column, and then we've got tenths in this column, hundredths in this column, and then thousandths in this column, and so on. Okay, so when we've got 0.507, there's a 5 in the tenths column, a 0 in the hundredths column, and a 7 in the thousandths column. And when I have 0.75, there's a 7 in the tenths column and a 5 in the hundredths column. So you're not comparing 507 with 75. We're looking at what's the biggest tenths, what's the biggest hundredths, what's the biggest thousandths, and so on. So you might find it helpful to put it in a table like this. Alternatively, you might find it helpful just to make the numbers the same length. So we've got tens, hundredths, thousandths, tens, hundredths, there is 0 in the thousandths column there, tenths, hundredths, thousandths, and then that's got tenths, hundredths, thousandths. So that might make it a little bit easier to compare. However, how we would do this, first thing we're going to look at is the units column, and they've all got 0 in the units column. So that doesn't help us compare. We then move across to the tenths column, and I've got a 5, a 7, a 5, and a 0. So hopefully we can see that this one is going to be our smallest number. We actually don't care about what's beyond that, because in the tenths column, which is the next most important column, it's got a 0. So I'm going to put 0.078 as the smallest one. And I'm going to cross it off so that I know that I've used it up and I don't get confused. I then know that the next smallest was between the ones that both have a 5 in the tenths column, but they've both got a 0 in the next column. And then in the thousandths column, this one's got a 0 and this one's got a 7. So 0.5, and I'm going to write it in the original format, is our next smallest. Then we've got 0.507, and then we've got 0.75, and that's going from smallest to biggest. So you might find it helpful to write them on top of each other like this. I didn't cross them out as I went along. That might help you to see where the smallest ones are, or to write them in a column like this, or just to put zeros on, or just to compare by column. Okay, here are 6 shapes. Which shape is congruent to shape E? So this is really just testing your definition of the word congruent. And congruent means that those 2 shapes are exactly the same. You can turn them, rotate them, or you can flip them over, reflect them. But essentially, if you cut them both out, you could fit them exactly on top of each other. So if you cut them both out on paper, they would fit exactly on top of each other. So looking at this shape E, we've got these 4 squares like this. Which shape is congruent is going to be A. If I cut them both out, they would fit over the top of each other. So my answer is A. There are no other congruent shapes there by the looks of it. I don't think. Oh, yeah, no, C and D. I've skewed the image slightly, but if they were actual squares, C and D are also congruent because they're exactly the same. So congruent means that 2 shapes are exactly the same in shape and size. They're not a bigger and a smaller version. They're exactly the same. And if we cut them both out, they would fit on top of each other. We could turn them and flip them, but that's what congruent means. Okay, work out 5/7 of 168. Now, when we want a fraction of a number, which you might see written like this, it means exactly the same thing. A multiplication sign in maths means of, okay, or of multiplication is the same thing. We're going to divide by the bottom, and then whatever we get, we're going to times by the top. So first thing I'm going to do is 168 divided by 7. Now, that's quite tricky, so I'm going to use my bus stop method. 168 goes inside the bus stop and 7 goes on the outside. How many 7s go into 1? Well, that goes in 0 times, and we're going to carry that 1 over. How many 7s go into 16? I've got 7, 14. That's 2 lots. So it fits in twice. And there's 2 left over because 2 lots of 7 is 14. 2 left over, so carry the 2. And 7 into 28 goes 4 times. So that's 24. So 1/7 of 168, if I draw it as a bar, 1, 2, 3, 4, 5, 6, 7, 1/7 is 24. So we've divided it into 7 parts. So we've divided by the bottom, and we're now going to times by the top. I don't just want 1/7, I want 5/7. So 1, 2, 3, 4, 5, 24 times by 5. 5 times 4 is 20, so 0 carry the 2. And 5 times 2 is 10, add the 2 is 12. So 120 would be my answer. We've divided by the bottom, and whatever we got, times it by the top. A new TV is priced at £320. In a sale, it's reduced by 45%. Calculate the sale price. So we need to work out 45% and take it off. So I'm going to do that by saying 10% and then timesing it by 4. So let's first say what 10% is. So to get 10% of a number, we would divide by 10. This is 100%. I want 10%, so I'm going to divide it by 10. So dividing this by 10 is £32. So if you've got a number and you want 10%, you divide it by 10. So 10% is that. So 40% is going to be 4 of these. So I'm going to do 32 times by 4. 4 times 2 is 8, and 4 times 3 is 12. So that's 128, and we're almost there. I've got 40% now, but I want 45%, so I need to know what 5% is. Now, you've already worked out that 10% is 32, so 5% would be half of that, and half of 32 is £16. So if I want 45%, I can add these two together. So 128 add 16. 8 add 6 is 14, carry the 1. 2 add 1 is 4, and then I've got 1. So that's my discount. I get £144 off the TV. So that's not going to be our final answer. Our final answer is going to be taking that away from the 320. So I'm going to do 320, take off the discount. Now, when we're subtracting, if there's more on the floor, we borrow from next door. So more on the floor when we're subtracting, borrow from next door. I can't do 0 take away 4. There's more on the floor. I'm going to borrow and make that 10. So I've borrowed 1 from here to make this 10. 10 take 4, we can do that. That's 6. 1 take 4, we can't do. There's more on the floor. Borrow from next door. 11 take 4 is 7. And 2 take 1 is 1. So the price of a TV is £176. The only other way we could have done that is we could have said, if we're taking 45% off, then we want, if we start with 100% and we take away 45%, we want 55%. So we could have just worked out 55% by halving it and adding on 5%, but we'd have got the same answer, so that's okay. Okay, expanding brackets. So to expand this bracket, we're going to do 4 lots of y and 4 lots of 2. Everything in the bracket needs to be times by 4. This says 4 lots of this bracket. 4 lots of y is 4y, and 4 lots of 2 is positive 8. And that's my final answer. These are not like terms, so we would not add them together. If it was 4y add 8y, we could make that 12y. But because it's 4y and 8, they're not like terms, that's our final answer, 4y add 8. For the second one, we need to times y by everything in the bracket. So I'm doing y times 3y. Now, y times 3y, we've got a y times a y there, and that's timesing it by itself, and that's going to give us a y squared. So y times 3y is 3y squared. And then I'm doing y times 5. Now, if you want, you can do little multiplication signs on these arcs to help you remember. So y times 3y was 3y squared, and y times 5 is 5y, and it's positive 5y. So that's my final answer. And again, I can't add them together because they're not like terms. That's my final answer. Okay, factorize means going the other way. So when you're asked to factorize something, they're saying put it into brackets. And to put it into brackets, we need to look for a common factor. So that word factor there. What is the highest common factor of 15y and 20? Well, what's the biggest thing they have in common? And they're both in the 5 times table. So I'm going to put 5 outside the bracket. And factorize means put into brackets. They're both in the 5 times table, so 5 goes on the outside. How many 5s go into 15y? Or what would we need to times with 5 to get 15y? Now, to get 15, we're going to need to put 3 here, because remember, it's timesing. And we also need a y. And then add 5 times what is going to make 20? We need to make this a 4. So essentially, we're going backwards of what we've just done. We're saying what would multiply out to give 15y add 20. So 5, open brackets, 3y add 4. And you always want to take the biggest thing outside the bracket that you can. Okay, so if there was, let's say they were both in the 4 times table and both in the 8 times table, you'd take 8 outside the bracket because we want to take as much out as we can. Okay, second question. What have these terms both got in common? Well, they've got no numbers in common because there is no, well, this is just one lot of a squared, but they have an a in common. This can be divided by a and this can be divided by a. So for this question, I'm going to put a outside the bracket. Now, a times what is a squared? We know that a squared means a times by itself. So a times another a would give us a squared. Add, and then a times what to make 3a, and that would be a 3. So if I want to check that my answer is correct, I could do a times a, which is a squared, and a times 3, which is 3a. So again, we've put it into brackets. I'm just going to write it again over here on the answer line. And that's my final answer. Okay, at a rugby match, the ratio of children to adults is 2 to 3. There are 80 children in the crowd. Each adult ticket costs £8 and each child ticket costs a quarter of that. Work out the total money made from ticket sales. Okay, so we've got the ratio of children to adults is 2 to 3. So this is children to adults, 2 to 3. There are 80 children in the crowd. Now, when we have ratio questions, normally we need to add together how many parts we've got. So in this case, there are 5 parts. So 2 to 3, like this, and divide by that. But we've not been given all of the people. So we're not going to divide by 5 on this one. We're going to divide by how many parts this is worth. Now, if there are 80 children, then we know that this side, the 2, needs to be 80. Now, the wonderful thing about ratio is that we get the same amount on every single line. So I've got 40 here and 40 here. And if those are both 40 to make 80, then these must be 40 as well. So if there are 80 children, there must be 120 adults. Each adult ticket costs £8. So we're going to do 120 times by 8 to find out how much money we're getting from the adults. And each child ticket costs a quarter of that. And a quarter of 8, half it and half it again, is £2. So we've got 80 children, each paying £2. So 8 times 0 is 0. 8 times 2 is 16, so 6 carry the 1. And 8 times 1 is 8. Add the 1 is £960 coming from the adults. And from the children, 80 times 2 is 160. Adding that together, because we want all of the money from all of the ticket sales. 0 add 0 is 0. 6 add 6 is 12, so 2, carry the 1. 9 add 1 is 11. So £1,120. Okay, multiplication of fractions. To multiply a fraction, we don't have to make the denominators the same. We only make the denominators the same for adding and subtracting. So for multiplying, we're just going to do the numerator times the numerator and the denominator times the denominator. So 1 times 3 is 3. 2 times 5 is 10. And then I would just want to check, can I cancel that down? And there's no common factors. There's nothing that goes into both. So that would be my final answer for that one. Nice and straightforward. If we're given a mixed number, 1 1/3 times 2 2/5, the first thing we need to do is make them both top heavy. So to make a fraction top heavy, to make it a single fraction, we need to do big times the bottom, add on the top. So big times the bottom, add on the top. So 1 times 3 is 3, add the 1 is 4. So we have 4, and our denominator always stays the same. So it was 3 on the bottom here, so it's 3 on the bottom here. Times by, and again, we're going to do big times the bottom. So 2 times 5 is 10, add 2 is 12. So that's how we're getting our numerator. Big times the bottom, add on the top. So 2 times 5 is 10, add 2 is 12. And again, our denominator stays the same. Now, to times this, again, we're going to do the numerator times by the numerator. 4 times 12 is 48. And 3 times 5 for the denominator is 15. Now, we're not going to leave our answer like that. It says give your answer as a mixed number. So we need to say, how many 15s go into 48? Now, I like to think about a clock when I think about the 15 times table. So 15 minutes, 30 minutes, 45 minutes, 60 minutes. And that's already more than we need. So we would fit that in 3 times. So 15 goes into 48 3 times, 3 whole times, and we've got 3 left over out of 15. But we're not done. Always we have to check this fraction, does it simplify? And because they're both in the 3 times table, yes, it does. So we've got 3 wholes and 1/5. I've simplified this fraction because they were both in the 3 times table, divided them both by 3 and got 1/5. Okay, question 4. Shown below is a regular pentagon ABCDE. Now, a pentagon, we should know that in a triangle, the angles add up to 180 degrees. In a quadrilateral, a 4-sided shape, the angles add up to 360 degrees. And in a pentagon, a 5-sided shape, again, we go up by another 180 degrees. So that would be 540 degrees. So in a pentagon, 540. Now, this is a regular pentagon, which means all of the angles are the same. So I've got 1, 2, 3, 4, 5 angles here in my pentagon, and they're regular, so they're all the same. So I'm going to do 540 divided by 5. 5 into 5 goes once. 5 into 4 does not go, so we need to put that 0 in there, and we carry the 4 over. And 5 into 40 goes 8 times. So I now know that each of these is 108, 108, 108, 108, and 108. But I'm not going to label these two actually, because that's a little bit confusing because I don't actually want the full angle there. Okay, so I know now that X is 108 degrees. Now, because it's regular, all of these sides are the same length. So this triangle here is an isosceles triangle, which means that it's got 2 sides the same and 2 angles the same. So this angle here would be the same. I know in a triangle it adds up to 180 degrees. So I'm going to do 180, take away 108. And again, we've got more on the floor. I'm going to borrow from next door. 10 take 8 is 2. 7 take 0 is 7. And 1 take 1 is 0. So I've got 72 degrees left to share between these two. And because they're the same, they must be half each. And half of 72 is 36. So Y is 36 degrees. We've got 36 degrees on this side and 36 degrees on this side. Okay, a pictogram next. The pictogram shows the amount of money raised by students in some tutor groups at a school. So a pictogram is often giving us a key here. So we know that every circle is worth £10. It says complete the raised column. So complete this column for how much was raised. Okay. So we know that every circle's £10. So 10, 20, 30, 40, 50, £60 was raised by tutor group S. 10, 20, 30 for tutor group T. We'll fill in E in a minute. And for P, we've got 10, 20, 30. And then half a circle would be worth £5. So 35 for that one. And similarly, if we're going to fill in E, we know it's 10, 20, 30, 40, 5. So again, we need half a circle like that. How much money was raised altogether? Well, to get that, we need to add up the end column. Or to be honest, it might just be quicker if we count the circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then the two halves make 17. So we've got 17 times 10, £170. And we could check that by adding up this column. You can take my word for it. £170. Okay, the cuboid and the cube below are placed on the floor. The cuboid, that's the pink one, has a weight of 60 newtons, and the cube has a weight of 40 newtons. Which exerts, so which gives, a greater pressure on the ground? You must show your working. For this, we need the formula pressure, force, area. So it's another triangle to remember. Pressure, force, area. If I want the pressure, I'm going to cover that up and do the sum that's left behind. So that would be force divided by area. Force divided by area. So for the cuboid, to get the pressure, we need to do the force, which is 60 newtons, divided by the area that's on the floor. So the area that's on the floor is going to be the area of the face on the underneath. And the area of that face would be 8 times 3, so 24. The cube has a force of 40 and an area. So what is the area going to be of that shape, the square that's on the floor? And I know it's a square because it's a cube. So it's going to be 4 times 4 times 4. So for the bottom face, it's just going to be 4 times 4 because it's 4 that way and 4 that way. So 16. Now, this annoyingly is a calculator question, but your paper is a non-calculator, but it wouldn't be those numbers if it was going to be on your paper. So 60 divided by 24 is 2.5 newtons per centimetre squared. So because we've done newtons divided by centimetre squared, the units is that. And for the cube, 40 divided by 16 is again 2.5. So they have the same pressure on the ground. Okay, pressure, force, area. Now, completely unrelated to that question, but also on our revision list at the minute, revision list at the beginning, we were asked to be able to work out the volume of a cuboid. So I just want to do that with this one here, completely unrelated to this question. So let's just do it up here. If I wanted to work out the volume of this, that's how much space there is inside the shape. And to get that, we do length times width times height. Or you could think of it as the area of the cross section, so the area of this face here, times by how far back it goes. That's going to get us the volume. So the area of that end face, 2 times 3 is 6. 6 is the area of the cross section, times by how far back it goes, which is 8. So 6 times 8, which is 48 centimeters cubed. So if we want volume, it's going to be in centimeters cubed. Okay, so it's length times width times height if it's a cuboid, but if it's any other prism, it's going to be the area of the cross section times by how long it is. That was not related to that question, but was also on our revision list, so good to know. Okay, question 5 is proportion. So Donna uses this recipe for chili con carne, and her recipe serves 6 people. And we've got the ingredients there. Donna is going to use this recipe to make chili con carne for 15 people. Work out how many grams of mince she needs. So if at the minute the recipe is for 6 people, if we double it, we would have a recipe for 12 people. So 6 and another 6 is 12, but we're trying to make it for 15 people. So 12 is not quite enough. We need another 3 people for our recipe. So 6 and 6 and 3. So 6 people, we know we need 1 kilogram of mince. Another 6 people, we know we need another kilogram of mince. And for 3 people, we know we would need half as much. So half of a kilogram, remember a kilogram is 1,000 grams. If I had 3K in my bank, K, we use the letter K for 1,000. 1 kilogram's 1,000 grams. So if I want for 3 people, it's going to be half of that, half a kilogram, which would be 500 grams. And we've been asked here to give our answer in grams. So we're going to add those 3 things together to find out how much mince we need for 15 people. And that would be 2,500 grams for 15 people. And that's it. Sometimes it's helpful. The other thing you could do is work out for 1 person or for 2 people, maybe. Well, 1 person in that case, or for 3, and then times it by 5. So sometimes that's a good way of doing it as well. Okay, here we need to write the number in words. So just say it in your head to yourself. So we've got 3 in the thousands column, and then we've got 8 in the hundreds column. We haven't got any tens, and we've got 4 in the units column. So we would write this number as 3,000, 800. We're not going to say no tens, and 4. So 3,804. That'll be for the mark there. Write the number 10,251 in figures. So 10,251. 10,251. Okay. Reflect the shape using the dotted line as a mirror line. Now, when we reflect shapes, we need to also reflect the gap. So when you look at a mirror, your face isn't pushed up against the mirror looking back at you. You've got that same gap on the other side. So when we reflect a shape, sometimes it's helpful to think, well, it's 1 square away here. So it's going to be 1 square away here. So let me use the blue. That corner is going to be that corner. And here we are 2 squares away. So we're going to also be 2 squares away on this side. And it's going to go there. So that's my first line. It's 4 squares across, 1, 2, 3, 4. It's 1 square across at the bottom, and then we're going to join that up. And that's my shape. You might want to reflect all 4 corners. So do all 4 corners and then join it up. That would be up to you. That would work as well. Okay, so reflecting from the mirror line. Right, rounding. So round the number 7.819 to 1 decimal place. So if I want it to have 1 decimal place, that means 1 number after the decimal point. So I want to keep this number here, and then I want it to end. Now, when we do that, we always have to check the next number to see, is it 5 and above, or is it less than 5? Now, because it's a 1, that means we're going to round down, so it's going to stay the same, and my answer would be 7.8. So you're using this next number to decide whether the 8 stays an 8 or whether it goes up to a 9. Okay, but in this case, the next number was a 1, and that's why it stayed as an 8. For the second part of this question, we're rounding the number to 2 decimal places. So I want this one, and I want this one, and I want to end it there. And again, we always check the next number. It's a 9, and that's going to round up. So my 1 is not going to stay a 1, it's going to go up to a 2. So 7.82 would be your answer to that one. So you're always checking the next number to see what happens to the one in front. Okay, this is a map of an island. A helicopter flies in a straight line from Leek to Donhampton. Leek to Donhampton. So we're going from here to here. How far does the helicopter fly? Now, do I have a ruler? Oh, maybe not. Not going to let me have it. No, okay. So we would measure this. Obviously, on paper, it's going to be a lot easier. We would measure this here and see how far it is. Let's say, for example, we measured it and it was, let's just say it was 8.6 centimeters. Let's say we measured it like that. We're going to look down here at the scale. Obviously, the helicopter in real life did not fly 8.6 centimeters. In real life, every centimeter is 10 miles. So if I know it's 8.6 centimetres, to get it in miles, I need to times it by 10. So 8.6 times by 10 is 86. Remember, we're moving all the numbers one place to the left to times by 10, so 86 miles. Then it says, write down the bearing of Donhampton from Leek. So write down the bearing of Donhampton from Leek. Now, the bearings, okay, start north and go clockwise. So if I had a line like this, I would measure this degree, and let's say that was 45 degrees, and I would say the bearing is, now bearings, we have a special rule where we always have to write 3 digits. So if it's less than 100, you have to say 0.45, for example, degrees. Okay, we have to put a 0 in front. So bearings, you start north and you measure the angle going clockwise. Now, if it says write down the bearing of Donhampton from Leek, I need to go from Leek. So I'm going to be measuring from Leek. Now, what we need to do is draw a line going north because that's our starting point. And I want to measure the angle to Donhampton from Leek. So I'm measuring this number of degrees. Definitely not going to let me get this. No. So I would get my protractor, the measuring thing, and I would put it so that 0 was north. That's going to be that way up, that orientation. So 0 is north. You know the thingy that looks like this? I mean, that looks like a pasty, but hopefully you get what I mean. You put your protractor that way up. So 0 is facing the top, and we're going to put it here like this, and then measure, and however many degrees that is, that would be our answer. Now, it looks to me, if that's a right angle 90 degrees, maybe it's a little bit more. So something like 130 degrees for this one. Obviously, you'd measure it accurately if you had it on paper in front of you, but you're going to start facing north. So 0 should be north, go round until you get to the line that you want. So let's just say it's 130 degrees. I'm not sure off the top of my head, but I can't get the thing up. So you have to, yeah, bear with me. Okay, solving equations now, and these are two-step equations because we have to do two things. So I find it really helpful when I'm solving equations to put a dotted line where my equals is. And remember with equations that what we do to one side, we have to do to the other. So when we solve an equation, we're trying to work out what the letter is, what y is. Now, this 4 is annoying. At the minute, y is being multiplied by 3, and then we're adding 4 and we're getting 22. So the first thing we're going to do is take 4 away from both sides. Now that leaves me with 3y on this side. I've got rid of the plus 4 by taking away 4. And on this side, I've got 18. So 3y is 18. I've got rid of this, and I've taken 4 away from this side as well. So what we've done to one side, we've done to the other. Now, 3 lots of y is 18. What does 3y mean? It means 3 lots of y. So this is multiplying. So to get rid of the 3, we're going to divide by 3. That's the opposite. We're undoing it with the inverse operation. But if I divide this side by 3, I will get y, which is great. That's what I want. But I also need to divide this side by 3. So 18 divided by 3 is 6. Sorry, that's annoying. I should have done that in black. There we go. So y is 6. And we can double check our answer by putting it back in to the question. So 3 lots of 6 is 18. Add 4 is 22. So it works. So y is 6. And that's our final answer. Okay, with the next one, again, I'm going to do my dotted line where the equals is. First thing I'm going to do is take 3 away from both sides. If I take 3 away from this side, I'm going to get rid of that. But I also have to take 3 away from this side. So I'm then left with, let's use the blue one, c over 2, I've not touched that bit, equals 7. Okay, now what is happening to c? At the minute, c is being divided by 2. The line in the fraction means divide. So if it's being divided by 2, we need to times by 2 to get rid of that. And that would just leave me with c on this side. Okay, I've got rid of this division because I've times by 2. But if I'm going to do that on the left-hand side, I need to do that on the right-hand side as well. So c equals 14. And that's my final answer. Let's double check. What is 14 divided by 2? Well, it's 7. Add 3 makes 10. So we know we've done it right. Okay, Olivia has blue, pink, and orange counters in a bag. the ratio of blue to pink to orange, blue to pink to orange is 4 to 5 to 2. So the order of the words is always the order of the ratio, blue to pink to orange. What fraction of the counters are blue? So if I'm asked what fraction, I would say this number, 4, out of, so this is for A, 4 out of, well, how many parts altogether? 4 add 5 add 2 is 11. So the fraction of counters that are blue is 4 parts out of 11 parts. So 4/11ths are blue. For B, what fraction of the counters are orange? So orange is 2, and it's still going to be out of the same number, 4 add 5 add 2, 11. Okay, so for this question, we're going to write the ratio in the form 1 to n. Excuse my scribbling. We're going to write the ratio in the form 1 to n. And all that means is we're going to change the ratio so that the left-hand side is a 1 and the right-hand side is whatever it needs to be. Now, normally we don't make ratios have decimals in them. But if we've been told to make the left-hand side 1, then we're kind of stuck. We need to do whatever we need to do to make the left-hand side a 1. So if you look at this first example, how would we make this left-hand side a 1? So if I wanted to make it a 1, I've had to divide this side by 10. And if I do that to one side of a ratio, I have to do that to the other as well. So dividing this by 10 gives me 1.3. So that would be my answer. My answer for that first one would be 1 to 1.3. I've kept the ratio the same because I've done the same to both sides, but most importantly, I've made the left-hand side 1, which is what we were asked to do if we're asked to give it in the format 1 to n. So n can be whatever, but the left-hand side has to be 1. With the next one down here, again, I want to write it in the form 1 to n. To make the left-hand side 1, we need to divide this side by 5 because we're trying to go from 5 to 1. If I do that on the left-hand side, to keep the ratio the same, I need to do that on the right-hand side. So this would also need to be divided by 5. Now, 7 divided by 5 is quite tricky. We can divide by 10 and double it, or that might be more likely to be on a calculator question. So 7 divided by 5 is going to be 1.4. So again, my answer for that one would be 1 to 1.4. So you've made the left-hand side 1 by dividing by whatever you need to divide by, whatever the number is. And you have to do the same to both sides because it's a ratio, a bit like a fraction. What we do to one number, we have to do to the other. And I think that is it. So well done if you managed to have a go at all those questions. I hope this was helpful and good luck for your assessment tomorrow.